Hello, welcome back to Mr. Miles Maths. Today we're going to look at our second lesson on Pythagoras Theorem. It's good to know from the first lesson nothing changed in terms of Pythagoras. I'm just raising the level of difficulty of the question and you'll hopefully see what I mean when we get stuck into it. So we'll do a quick recap of Pythagoras Theorem and then we'll get straight into the questions which test you a little bit more on your algebra and your equation solving skills and your problem solving skills rather than just can you apply a theorem to a particular question. So let's have a look at the first one. So this question, first thing to note is that Pythagoras theorem is used to find lengths and distances. So if you're asked to find x where x is a length or a distance, then Pythagoras might be useful if it's a right angle triangle in particular. And we recognize that with a little square in the bottom corner highlighted there. So when we use Pythagoras theorem, we should know the theorem off by heart now. A squared equals b squared plus c squared. Remember, if you've learned it slightly differently, that's fine, so long as the hypotenuse is the one by itself. And the hypotenuse, remember, is the longest side of a right angle triangle and it's always opposite the right angle. And my recommendation is to label the triangle first. So opposite the right angle, we always label A. Might be slightly different if you've been taught differently, that's fine. Just stick with the formula that you've been taught and use it in the same way. B and C don't matter, so here's B and here's C. And then I can substitute into my Pythagorean formula. So nice and easy now. A is here, A is 3x. Now, the mistake people often make here is that they put 3x squared in like this. But when we're looking at a squared, we're looking at the whole length squared. And the whole length is not just 3x squared, which means 3 times x squared. It's 3x, which is the length, all squared. So whenever we substitute, and I mentioned this in the last video, we always use brackets. Sometimes you get away with it, other times you won't. And if you always put those brackets in, you won't need to get away with it because you should always get it right. So when we substitute in A is 3x. So when I do 3x, a squared is 3x all squared. And to indicate that, I put it in a bracket. And then I need to know how to deal with squaring out a bracket, but we'll talk about that in this question as well. And you'll find it on some algebraic simplification videos too that I've done. B is 2x. So in the same kind of way, when I put 2x in for B, it must go in a bracket because I'm not just squaring x, I'm squaring the whole length, the whole of B, which is 2x all squared. C is 4.6, so that can go in a bracket as well. C squared, here's C down here, 4.6, and I can put that in there. Okay, and all these questions, we're trying to find the value of x. Okay, I should have mentioned at the start. So find the value of x. Okay, now we need to know how to solve this equation properly and manipulate the algebra properly. So 3x squared means 3x times by 3x. So I need to multiply the 3's together to give me 9, and I need to multiply the x together to give me x squared. So 3x squared is actually 9x squared, different from 3x squared, which is 3x squared, 3 multiplied by x squared. This is 3x all squared, so 3x times by 3x. And the trick here is to square the 3 and square the x, and you can do it in one fell swoop. Same with the 2x all squared. I square the 2, which is 4, and I square the x. So this will be 4x squared. And then when I square 4.6, I can use my calculator to help me. So 4.6 squared is 21.16. And then I need to be able to solve this equation. So Pythagoras theorem hasn't changed. I'm still using a squared equals b squared plus c squared. I'm still subbing in using brackets. The harder part of this is making sure I use brackets correctly and then how I manipulate and deal with this and solve this equation. So I want to get the x squareds by themselves. I've got x squared on both sides here, don't like that. So I'm going to subtract the 4x squared from both sides because that will remove it from the right and leave me with just 21.16. When I subtract 4x squared from the left, I get 9x squared minus 4x squared, which will just give me 5x squared, 5 lots of x squared. And I won't write all the hints down at the side, just here and there, just to give you a little bit of guidance. So subtract 4x squared from both sides. I then want to get the x squared by itself. I don't like the 5 in front of it. The 5 is multiplying the x squared, so to get rid of that, I divide by 5. So I divide this side by 5, and either you can write it as a fraction, and 5 won't go into 21.16, or you could go straight to your calculator and divide by 5 to get your decimal. Okay, it's entirely up to you which you want to do. Most people like to have the decimal, that's fine. I prefer fractions in general, but I don't mind the decimal here. And then to get rid of that square, I'm going to square root both sides. So the square root of 4.232. And when I get that, I'll have my answer. And I will decimalize this now because it is my final answer. So 2.057, it goes on, and I'm going to round that to 3SF. So the 5 is a third significant figure, the 7 rounds that up to a 6. It's in centimetres, so I put my units, and I've done it to 3SF. So I should always have my degree of accuracy. So Pythagoras' theorem hasn't changed. The difficulty of the question is just harder because the algebra involved, once you've got the Pythagoras' theorem done and you've substituted in, that's what makes this question more difficult. Okay, similar kind of idea, second question. So again, right angle triangle, lengths, we can use Pythagoras. So opposite the right angle, we're going to call A. B and C don't matter. And then I can write my formula down, A squared equals B squared plus C squared. Just give myself a bit more room there. And then I can sub in. So because it's all been labelled nicely, I can see my A. Here's my A, x plus 3. But again, because I'm subbing in x plus 3, I put it in a bracket here, but it's really important that that bracket remains when I sub in. So A squared is x plus 3, the whole length squared. And I've got to put in a bracket. I can't write x plus 3 squared like this, because we know, well, we should know from bid maths, that means I'd have to square the 3 first and get x plus 9, that'll be it, which is a completely different thing to do an x plus 3 squared, which means mathematically x plus 3 multiplied by x plus 3. So we need to know how to deal with expanding brackets. B is x minus 1. Here it is. So that can go in again, must go in a bracket. And then C is just 5.8, which I've now rubbed out by mistake. Sorry, 5.8. So that goes in here in a bracket squared as well. If you don't know how to square brackets or multiply brackets, you need to go back and watch the videos on that or practice that skill. I'm going to use a shortcut method here, and the shortcut method for expanding is that you square the first term, x squared, you times x by 3, 3x, and double it, 6x, and you square the last term, 3 squared is 9. Same with this one, square the first term, x times x, times minus 1 by x and double it, minus 2x, and then square minus 1 times minus 1 is positive 1. And then 5.8 squared, I can just quickly pop into my calculator and get 33.64. If you're not sure how to square a bracket quickly, you can just write it out as 2 brackets, and then methods for that, I would probably recommend doing the first term times everything in the second bracket, and the second term times everything in the second bracket. But if you can learn the shortcut, that'll be the best way of doing it. I have got videos on expanding brackets, which will include that shortcut method and the full method as well. So I advise looking at that before you do these questions. There are x squareds on both sides here. So I can subtract x squared from both sides, and that means they will just cancel each other out. Again, I can write that a bit more simply, just a 6x plus 9 on the left. I'll have minus 2x, and I can add the numbers on the right. 1 plus 33.64 is 34.64. And then I need to gather all my x's on one side. I don't have a squared x here, that's fine because they cancelled. So I just need to solve this how I would usually, get all the x's on one side. And I'm going to do that by adding 2x to both sides to get rid of the minus 2x. So add 2x to the left, 6x plus 2x is 8x. The 9 tags along. I've added 2x, so the minus 2x will disappear. So I'll just be left with the 34.64. Subtract 9 from both sides to get rid of this 9. So I'll have 8x on the left, 34.64 minus 9. I should probably be able to do that without my calculator, but just to make sure, it's 25.64. And then how do I get from 8 times x to x? I want to divide by 8 to get rid of the timesing by 8. So I'm going to divide this other side by 8 as well. Whatever I do to one side, I do the same to the other. And then I can get that in my calculator to give me 3.205. It does terminate there, so I don't need dots. And then I could round this to 3.21. Again, it's all in centimetres. And I should write my degree of accuracy to 3SF. Pythagoras hasn't changed. It's still right angle triangles. It's still a squared equals b squared plus c squared, where a is the hypotenuse opposite the right angle. What's more difficult is the algebra involved in solving. And that's why it's so important to watch all these videos on equation solving right from the start so you can build up your answer. One more question. It's a little bit trickier. Number 3. It's kind of a multi-stage problem. But again, it's still finding lengths. It's still right angle triangles. We've got that in the corners. So we can use Pythagoras here. So if I look at where x is, in order to find x, I would need this length along here, which I should be able to spot quite quickly will be the 6.7 minus the 2.6. That'll give me the difference between those two things. So 6.7 minus 2.6, which is 4.1. So that'll be helpful. I can write that in straight away. If I can use the information, then you use it to help you. There's a reason why they've given you those two lengths, so you can find the difference and find that other length. So the length that I now need, I'll label it with a big capital X for now, is that length. If I've got that length and I've got 4.1, I can use Pythagoras to find x. But I don't have this length, which I'm now going to call y so I can use it. I don't have that length. So I'm going to see if I can find that length from the other information I've been given. And I can see that from this left-hand right-angle triangle, I have the hypotenuse and I have a length. And that means I can find y from that using Pythagoras. So that's the first kind of thing I'm going to look at. I'm going to look at this triangle here on the left. Which looks a bit like this. And I've got 3.9 here, 2.6 here, and I've called this y. I don't really want to call it x because x is already in the question. And if I start using x, it suggests that they're the same length when they're not. So I'll just use a different letter. It doesn't matter, I can pick any letter that I want, just not x. So there's my little left-hand triangle, and I'm going to use Pythagoras' theorem on this. So opposite the right angle is A, B and C don't matter. And this is a nicer question than the ones we've done today so far. A squared equals B squared plus C squared. A is 3.9, always use brackets. B is just y, always use brackets to sub in. And C is 2.6. The y won't change, so y squared just stays as y squared. 3.9 squared is 15.21. So I can evaluate that. Same with the 2.6 squared to make it a bit easier for me. 6.76. Oops, managed to zoom out there. 6.76. How do I get the y by itself? I want to subtract 6.76 from both sides to start with. So my y squared will stay there. 15.21 minus my 6.76 is 8.45. And if I want to find my y, I can square root that. But y is not the answer because I'm asked for x. So I get 2.906. So I don't want to round this. If I round this and try and use it, I might get rounding errors. I'm going to talk about a little trick we can use in a second. So that means I've now got this length here, this length y. And now if I look at my other triangle, which is this kind of bigger one on the right hand side, looks a bit like this. Excuse my lack of ruler. Then I've got my y here, which is the 2.906-ish. I've got my x out here, and I've got the 4.1 that I worked out earlier. And I'm not using units here because it just complicates things. I know that I'm going to write centimeters at the end. In fact, I tricked myself on this one. This one was meters. I threw that in to throw you, and I threw myself. So just be careful that you pay attention to the units in the question. So this last one. Now we can label this again. I'm going to use A, B and C here just because the theorem stays the same and they're all going to be substituted for or accounted for. So A is the x, so that goes in, x squared in brackets. B squared, if you think about what B is this. I could put that in, but this is also y, isn't it? I worked out y in the first part. And I know y squared is 8.45. So if I put that 2.906 in and square it, this is the little trick, then I know I get 8.45 out because I'm kind of working, I'm almost substituting for y squared rather than y. If you want to go the full way, that's fine, like I've shown here, but that should work out as 8.45. I want to keep the exact number in my calculator. If you want to store it as a letter, that's fine. I'll do a video on storing for you so you can watch that. And C is 4.1, so that goes in brackets here. X squared stays as it is. This 2.906 squared is 8.45 because I've got it in this part of the question here. When I square it, I'll be going back up that equation, wouldn't I? So y squared is the same as the 2.906 squared, which is 8.45. And then 4.1 squared is 16.81. And I can solve, so add these two together. So 16.81 plus 8.45, which is 25.26. And then we can square root to get rid of the squared. Root 25.26. And as you get better, you might want to omit that step because it should be obvious if I go from here to here what I've done. And then I can round to 3SF, the 5 rounds the 2 up to a 3, and I will check the units this time, it is centimetres, and it will be 3SF. So it's just a double Pythagoras theorem question here. But if you can do things like this, you're applying Pythagoras theorem, and you have a much better chance of solving anything if they just had to tweak the question rather than just throwing a bog standard question. You can get things like 3D Pythagoras, 3D trigonometry as well when we come on to doing trigonometry, more triangles, and we'll look at more videos that help you with those things. So then the 2 lessons on Pythagoras, that's all you need to know about Pythagoras really. The theorem is the simple theorem, a squared equals b squared plus c squared. Make sure you label the hypotenuse correctly as the a. It's the longest side opposite the right angle. Sub in using brackets, that's the most important thing. And then you just need to practice your algebraic manipulation and you'll be able to solve all the kind of styles of equation that they throw at you. Hopefully this has helped extend your knowledge of Pythagoras. If you've enjoyed the video, please hit the like button, please hit the subscribe button, and look out for those other videos that might help you with this, such as expanding brackets or squaring numbers, all those kind of things. Thank you, see ya.